Okay, so we're solving trig equations today and tomorrow. This is our week of one day, one thing, and moving through those. These are things you guys need to see. We're pretty much at a level of just what you retain, and we will get the assessment on that on your final. So when we do your final, there'll be the final as a whole, and this section's over solving, using inverses, solving equations, and log signs and log cosines will be its own little quest also. So just so it's not all in that final for you. Okay, again, rules apply. When we solve equations, it's like reverse order of operations, right? We add or subtract things over, then we divide. But we need to remember that the sign of x, that's my whole unknown that I'm solving for, not just x. We'll get to the x eventually, but not right at the beginning. Okay, so on this picture, you don't really need to write anything down here. I just want to make you aware of, here's a sine curve. This black curve is a sine curve, yes? And I know that because it goes through 0, 0, right? Now, if I ask you where a sine of x is 1/2, so we answered questions like that last week, right? Where is sine of x 1/2? Well, that's at pi over 6, correct? Yeah. And then we have all these other things that happen. So what we need to be visualizing is here's the curve, and this dotted line, this red dotted line is 1/2. It's going to hit this infinitely many times, isn't it? Okay, so if we had an answer between 0 and 2 pi, it would be pi over 6, and then we would get another one here at 5 pi over 6, right? Yes?
Yeah.
Okay, so if I wanted just to count this one, how far apart is this and this point? 2 pi? 2 pi, right? Then if I did 5 pi over 6, it would be plus 2 pi, correct? Mm-hmm. Okay, so that would be in one, that would be all of them, right? The easiest way to do that is if I wanted all of the solutions, if I wanted the solutions between 0 and 2 pi, I would say pi over 6 and 5 pi over 6, yes? If I wanted every single one of these, I would actually say pi over 6 plus 2 pi n, because n means all of the rotations, right? And then 5 pi over 6 plus 2 pi n. And they always say the n can be negative. I don't think you count negative times. I don't, so that's why I put the plus or minus. But it still does it, because we have minus 2 pi, right? So if I ask for solutions between 0 and 2 pi, my answer would be theta is pi over 6 and 5 pi over 6. If I asked for all of the solutions, it would be pi over 6 plus or minus 2 pi n and 5 pi over 6 plus and minus 2 pi n. See the difference? So when they ask for just between 0 and 2 pi, you just answer 5 pi over 6. Make sense? And if they want all, what do you throw on the end of it?
Plus or minus 2 pi.
Plus or 2 pi n. That's the period, yes? If it was tangent, would it be 2 pi? What's the period on tangent? It's only pi, isn't it? Because it's pi between the asymptotes. So it would be plus pi n. So it's just the period. Changing it. So let's get to this. And you know from solving equations, there is no possible way I could give you every single example, right? You just need to think about what I need to do. When we solve an equation, we isolate the variable on one side of the equation, yes? Yeah. And then do what else we need to finish about. So I need to use variables to one side and everything else to the other. So what are we solving for here first? Not x.
Negative
Sine of x. We're solving for sine of, we are going to eventually get x, yes. But we got to get sine of x first, then we can do what we need to do, okay? So I need to move the sine of x's to the left or to the right. Which one do you want to do?
Left, right, left, right, right.
To the right.
To the right? Okay, because on the right we have a negative sine x already by itself, don't we? Okay, so we're going to, how are we going to move this sine x?
Subtract it.
Subtract it, just like we would any other time, right? So I have square root of 2 equals how many negative sine x's do I have? 2. Okay, so I just need sine of x now. Divide by negative 2. So I have sine of x equals negative square root of 2 over 2. Now it comes my exact values. Great review for exact values on our final. All this last week and this week have been. Okay, we are negative in what 2 quadrants?
Sine.
Sine is y, 3 and 4. What angle is my reference angle here? So pi over 4. So what's a pi over 4 in the third quadrant?
5
5 pi over 4. How do I know it's 5 pi over 4?
Because it's one more than pi.
1 more than a whole pi because, bless you, because pi is right there, right? Okay. What about the fourth quadrant? 7 pi over 4 because it is 1 less than 2 whole pi.
Yes.
So do you see how last week is going into this week?
Yeah.
I gave you just the answer last week. Like I already had it solved, didn't I? Now you have to get there this week. Yes.
Why is it? Oh, never mind.
Other questions?
Oh.
Okay.
Oh, I didn't get the second one.
Yeah,
Everyone write this down and then work on it. I'll go back. Got it written down?
No.
Cosine of x minus square root of 3 equals negative cosine of x. Are we good with this slide now? Can I start? You keep working.
Why don't you have a negative?
Did you have a negative divided by a negative? Okay, so did you get square root of 3 over 2?
No. Yeah.
Yeah, but I don't know.
Okay, so cosine's adjacent, yes?
Yeah.
So if square root of 3 is adjacent, then what's opposite?
30.
I'm not asking angle. If this is adjacent, what is opposite
Oh, 1.
of 1? So what angle is that? So pi over 6. Okay,
How is it? Why is it? Yeah, I thought it was.
Okay. Cosine is adjacent over hypotenuse, yes?
Yes.
So if square root of 3 is adjacent, 1 is opposite, and what angle is opposite of 1? 30.
I thought we were trying to find the square root of 3
Yeah, no, because it's cosine. Cosine's adjacent.
I don't know how you got negative 2 cosine x. I thought you had to add cosine x to the other side. Subtract.
This is positive, so you would have to subtract it.
Dude, you.
Okay, so it all goes back to my exact values, right?
How did you get?
Yeah.
I just did the exact value.
Okay, cosine is adjacent, yes? So adjacent to this angle is square root of 3, hypotenuse is 2. So
Yeah.
what is the opposite of square root of 3 is adjacent? 1.
Yeah, which is 6 or
which is 30, which is pi over 6.
I thought.
Okay, so we're first quadrant. And what other quadrant for fourth? Okay, so what's it in the fourth?
11 pi over 6.
Okay, so now I want all of them also. What do I do to get all of them? Add the period, yes. And the period is 2 pi, and can I do it as many times as I want? Yep,
How do you know it's 2 pi?
because that's the period of cosine,
Why are we doing all of them?
because I asked for them. Because the book will ask you between 0 and 2 pi and all of them.
What case would it not be 2 pi?
In tangent, anything where the period isn't 2 pi.
So this is like thinking of the graphs, right?
Yes. Yep. And they will all be 2 pi, they're not adjusted because we solved singular for the parent function. Okay? Does everyone understand that? This isn't, I don't have anything else on the left but the parent function, correct? And the period of the parent function is 2 pi. And, and that goes for sine, cosecant, secant, and cosine, yes? You won't be doing the other cosecant and secant, but, like, well, you may be. Sorry, don't take that back. But for tangent and cotangent, what's the period?
Always pi.
It's pi. Okay, so you just, those are things you need to know. Okay, so I have
gonna be pi for period. Oh wait.
for tangent and cotangent.
There's a sign.
We'll have to see where we end up. Okay, we have two different ones, right?
Yeah.
Okay, so I have 3 tangent squared x minus square root of 2 equals negative sine of x. So we do have a problem here. Can I change, do I have an identity that links tangent and sine together?
Sine over cosine or cosine over sine.
Okay, that, you do have that, but then you're bringing in cosine into it. Do I have an identity that only has sine and cosine together?
No.
Sadie, great job. She's looking in her
There's
notes.
so many in
It's
here.
where you guys should be looking.
Is it the Pythagorean?
It is the Pythagorean. Because what is in the denominator? Wait.
It's sine squared theta plus. Oh wait.
I'm wondering if I typed it wrong. Because it's the Pythagorean for tangent is what? Tangent and what? Secant. Okay? So I'm wondering if I typed it wrong. Which could be possible, right?
Or it's no.
This is 5, 3.
solution. No
Yeah.
solution. Here you go. So you're gonna keep your other job? Huh? You're putting your other one? Where do you apply? You got both of them? What would you pick?
I have no idea. Because for Sonic, I'm applying for this skater person.
I'm so good in that. I feel like I was last. Like if I saw you, I was last.
Okay, I'm going to change this to secant. Okay. Because you have an identity with secant and tangent, correct?
Yeah.
Okay. So we have one, Pythagorean is 1 plus tangent squared equals secant squared, correct? Okay, so if I have something that links that, I can change secant into tangent or tangent into secant, but if I did secant, I'd have to have a square root in there. Do you want to add a square root? I don't. Okay, so we probably should change tangent into secant, correct? Okay, so I've got to solve 1 plus tangent squared equals secant squared to make it tangent squared equals what? How would I get just tangent squared?
Subtract 1.
Subtract 1. So I have secant squared minus 1 equals tangent squared. So can I substitute that in here for this tangent squared? Yeah. So I have 3 times the quantity, secant squared minus 1, oops, I forgot my x, minus square root of 2 minus secant.
When did it equal?
Wait, is it
minus
equals?
secant?
Yes.
Wait, where did the X
My
come from?
brain.
It's in the.
Oh, I didn't see it in the.
Okay. So now what?
Now we're done. Now we quit.
Divide by
3.
Well, we could divide, I would divide by 3 if I had something on the right-hand side that was divisible by 3, but do I?
No.
No. But then if I also divide by 3, I'd have to divide the square root of 2 by 3.
Can
So
we
somebody said it,
distribute it?
distribute it. Once I distribute it, can I mess with it?
Yes.
Okay. Now, since I have something that's quadratic, I also probably need to set it equal to 0, don't I?
What?
If it's quadratic, the only way I can solve it is to set it equal to 0 and factor. So that's what I have to do.
Okay.
So I'm going to have to move this over as well. So I'm going to have 3 secant squared x minus 3 minus the square root of 2
Plus
Plus secant X.
plus secant of x. And that equals 0.
Why'd you, like, move secant?
Because since this is quadratic, the only way we can solve it is to set it equal to 0 and factor.
Now, if we really want to, we can add 3 to 0.
Yeah, add 3 to 0 and then divide
And add
3 from
square root.
secant.
No, it's quadratic. The only way I can do it is set it equal to 0 and factor.
Oh. No,
Okay.
No, I'll wait.
Is it in standard form or is it not?
Yeah, I'm not
I'll
bad.
do anything.
What?
Do we have to, like, put it in standard form or, like, just to move stuff around?
Oh, to rearrange it.
Yeah.
So you have 3 secant squared plus secant minus 3 plus square root of 2. And I'm hoping it's going to catch up. Yep. Equals 0. Now,
Where
I'm going
did
to
we
tell you what I just did. I took these two and I factored out a negative. So I know this is one thing. That's one number. I just can't add it without a calculator, correct? Okay. So I need to think about this. Remember that the secant squared is really secant x quantity squared, yes? Okay. So this whole thing in my brain should be seeing 3x plus x, 3x squared, excuse me, plus x minus that quantity, okay? Because I'm solving for the secant x. So I'd have to factor this, but I cannot factor this because I don't know the factors of that number because I don't know that number, do I?
Well, you know.
So what do I use if I cannot factor something? The quadratic formula. Okay? Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we've used that throughout the year. Whenever, anytime you have a quadratic, you have to set it equal to 0 and you have to factor to solve it. If you can't do your binomial factoring, then you have to use what? Quadratic formula. Sometimes the quadratic formula is just easier to use so you don't have to think about it, to be honest. Okay, so this is normally x equals, okay, but it's not going to be x equals anymore, it's going to be what? Secant of x. So secant of x equals, well,
Negative
a
x.
is 3, yes,
Yeah.
b is
1.
1, and c is
3 plus square root of 2.
that whole thing, right? Okay. And so I have negative b, so that's negative 1, plus or minus the square root of 1 minus,
12 times.
so we have 4 times 3, which would be 12, right? Times this negative, yes. So a negative and a negative would be a positive. So plus 12 times 3 plus the square root of 2. All over 6. Now, we have an answer, yes? Yes. Do we know what it is off the top of our head? Absolutely
Can
not.
we take 6 and the 12?
What?
Can we take 6 and the 12? Or no? Because it's times
Could we?
No.
Could we add the 1 and the 12?
No, because you have to do multiplication first.
Yeah.
Now, you could distribute this and have 36 plus 12 square root of 2. So then you could have 37 plus 12 square root of 2 if you wanted.
Or could
Or-
you leave the 1 and
You just,
divide 36 by 6?
no,
Yeah.
because it's in the square root, and this is a quantity, so you have to divide everything by 6. The easiest thing to do would be to pick up my calculator now and to do the answer. If you have something like this, all I want you to do is leave your answer like this. Got it?
Actually, we're gonna have something like this.
In your homework, you may. But if you have something like that, all I want you to do is leave it right there for now. Okay?
Is that one the Pythagorean theorem on the top right?
This is a Pythagorean identity. That's one of the 3 Pythagorean identities, yes. Then we also have 1 plus cotangent squared equals,
1 plus cotangent squared equals tangent.
cosecant squared.
Oh,
And you have sine squared plus cosine squared equals 1. So you have those 3. Hopefully the next one is going to be nicer. Yes, much nicer.
Done.
2 cosine squared x minus 1. So it's already set equal to 0, yes? That's nice. It is quadratic, so I have to, anything quadratic, I have to set it equal to what? And then what? Factor. Okay? So, I hope you guys see a difference of squares in there.
Yeah.
Because you have plus or minus, right? The problem with that is you have 2, and the square root of 2 is square root of 2. So since there is no other cosine term going there, could I add 1 and divide by 2? Can I do that? Yeah? Since there isn't a middle term, there's no b term, is there? No? No b term? So could I add 1 and divide by 2? Can I? So I have cosine, evidently cosine starts with an S. Cosine squared x equals 1/2. How do I get rid of x squared? Square root. And what do I need to remember when I take the square root? It's what? Is there one answer? It's plus and minus, correct? Okay, so the square root of 1 is what? 1, and the square root of 2 is the square root of 2, so I can't leave it like that.
It's square root of 2 over 2.
Square root of 2 over 2. So I want plus and minus. So how many times is cosine positive? 2. How many times is it negative?
2.
2. So how many answers are you going to have? 4. You're going to have all 4 quadrants, right?
Yep.
So first quadrant, it's a 45, so pi over
Pi over 4.
pi over 4. Second quadrant,
3 pi over 4.
third,
5 pi over 4.
fourth. Okay,
And it's
Now-
negative in the third.
it's negative
No, not the third.
in the second and the third, and
Second.
positive in the first and the fourth.
So do we need to write a negative sign?
No, because the angles aren't negative. The answer, that's the negative square root of 2 over 2. Now, we should always check and make sure it's going to work, right? Okay. So, well, when I put either of these in here, whether it's the positive or negative, and I square it, I'm always going to get a positive number, yes? Yes?
Yeah.
Okay, so if one works, should they all work? Yeah. The positive and negative is where it's going to mess you up sometimes. But once I square it, does it matter? No. Okay, so if I put it in there, so I have 2, and then I have the cosine of x, so it's square root of 2 over 2 squared, correct? Is it squared? So square root of 2 over 2 squared minus 1 should equal 0.
So that's 2 over 4.
So that's 2 over 4,
1/2 times 2 is
or 2 times 2 is 4.
over
It's all
4. 1. It's an equal
one.
1.
So do I equal 0?
Yes.
Yes. So do I need to continue to check them? No. Because that square is going to make them all positive and it's going to make the problem work out the whole way, correct? What happens if I don't square it? If I didn't square that, would the positives and negatives be the same answers? No. And it may not all work. So if you, for chance, you get those extraneous solutions, we've talked about those before, they're extra, you'll just draw a simple line through them. Don't cross them out. They're just not a good one, okay? Questions? Why did we do 4 answers?
Because it's plus or minus cosine.
Because it's plus or minus. What if I ask you for all of them? What?
All of those
Pi
plus
over 4
pi, 2 pi
plus
over
or
pi.
minus 2 square root of, no, 2 pi n.
So I have to add plus or minus what? 2 pi n
to all of them.
to all of them. Yes?
Yeah.
Ehu.
Okay, cotangent x cosine squared x equals 2 cotangent x. Throw something out there. Let's see if it sticks.
Minus cotangent of x.
Over to the other side. Get everything on one side, right? Okay. So I have cotangent of x, cosine squared of x. I like my parentheses. Minus 2 cotangent of x.
Wait, what? You mean equals? Oh, wait. Oh, well, I meant like minus the cotangent of x on the other side.
Oh, but this is multiplication on the left, so I can't subtract it. I'd have to do what?
Divide.
Divide. And the rule of thumb is you can move something, but you can't get rid of it. Everyone clear on that? So if I divided by the cotangent of x, would I get rid of cotangent of x?
No, you just move it.
Cotangent divided by cotangent is what? 1. Did I get rid of the function? Yes, I did. Okay. You can move it. Listen, you can move it, but you can't eliminate it. Because if you eliminate it, could you possibly be eliminating solutions? Yes. So I have 2 things on this side. Do they have something in common? A cotangent. So could I factor that cotangent out? Yeah. So I have cotangent of x times the quantity cosine, again, with the s for cosine. Cosine squared of x minus 2.
Why did you put it in brackets?
Because I have this parenthesis. I just chose to use brackets.
Wait.
So now I have 2 things, right? I have cosine here, yes? And I have cotangent here on the left and cosine on the right. The 2 functions have nothing to do with each other anymore, do I?
So you can.
What would happen if I had x and x minus 2 equals 0? You'd set them both equal to what?
0.
0. Okay, so I now have cotangent of x equals 0. And cosine squared of x equals 0. Oops.
Why not?
Minus 2. I just forgot my minus 2. Is that what you're going to get me on? Yep. I just forgot my minus 2. It does make a difference in the problem, though. Okay. So over here, I want to know where the cotangent of x is 0. Okay, so cotangent is adjacent over opposite, yes? Reciprocal of tangent. And for it to be 0, that would mean x has to be 0 and y has to be 1 or negative 1. So that happens on the y-axis? Yes? Which would be what? What's on? Pi over 2 and 3 pi over 2? So anytime I get 0 or zeros, I know it has to be a quadrantal angle, correct? Okay, now I come over here, cosine squared,
Wait, how did you get pi over 2 and 3?
because cotangent is adjacent over opposite. So that means in order for us to get 0, that means x has to be 0. And then y would be either 1 or negative 1. So that happens at,
Oh, okay.
okay, so,
Wait, is the 1 and the negative 1, is that because the max is in the mid?
okay, so how do I solve that one? Add 2. Now everybody's brain should be going, cosine can't equal 2, cosine can't equal 2, right?
No, cosine
But
can't equal
what's-
2.
What is there? Squared, so I have to take the what of both sides? Square root, because it's bigger than 1.
Oh,
Yeah. So I have the cosine of x equals plus or minus the square root of 2. Well, square root of 2 is still bigger than 1 or less than negative 1, correct? Isn't it? So is this a solution at all over here? Nope, so this is no solution.
Can you explain how it's not different?
Because it's more than one. Like the amplitude on cosine.
Remember, sine and cosine oscillate between what and what?
1 and
1 and
Negative 1.
negative 1. Oops, that's a positive 1. So you have to be in between 1 and negative 1 or it doesn't work.
So is that like an extraneous solution?
This is an extraneous, well, this is no solution at all. Over here, we may have an extraneous solution because it's an actual solution, it's just not a good one. So we gotta check them out. Gotta check them out. So I'm gonna plug them in here. I already know the cotangent is what at both of these?
0.
0. We already figured that out, yes? Well, 0 times anything is what? 0. So do they both work? Yes. Sometimes they don't. Okay? If it was addition subtraction, could it throw it off? Like that's in the original problem. Right back here. But we already know that the cotangent of x equals 0 when x is pi over 2 and 3 pi over 2. So if this is 0, 0 times anything is 0, and that would be 0 as well. When you check them, I don't need to see the work, okay? Some people choose never to check for anything. That's up to you. It's really not up to you. You should always check, but it's one of those things like when I tell Algebra 1 kids, you should never get anything wrong because you can always check your answer. Do you check your answer? No. Okay. Sine squared of x equals 2 sine of x.
Subtract 2 side of it.
Yep, set it equal to 0.
Are we only setting it equal to 0 on these ones because it's quadratic?
Yep. Now, if it was quadratic and there wasn't a sign on the right-hand side, like if there's no b term, you don't have to set equal to 0, you can move over. But it's just good practice, always on quadratic, set equal to 0, go from there. Okay, now what?
Sine of x.
Take out a sign.
Factor out a sign.
Yeah.
We've done that before, right? You're going to use your other problems, what you've done, to help you through the next ones. So I'm going to factor out a sign. And I will be left with sine of x minus 2.
And then set that equal to 0. Both of them equal to 0.
So sine of x equals 0. And sine of x equals 2. Can I jump there? Can I jump to that?
Yeah.
Okay. Right now, what's your answer over here?
Not possible solution.
Why?
Because it can't equal 2 without 1 and negative 1.
Love my pen. Now, it is not always going to be out of domain, but you need to be aware that anything bigger than positive 1 or less than negative 1 will be out of domain, right? Okay. Only on sine, cosine, secant, and cosecant, correct? Tangent and cotangent can be anything, because those go forever, don't they? They look like your little chairs. Okay, so sine is 0. That happens only on a quadrantal. Sine is what variable, x or y? Y. So,
Negative y equals 0.
Pi and 2 pi.
0 and
Wait, why is that?
because y, sine is y.
Oh, okay.
Yep. And the reason we did 0 and pi is because your domain is going to 0 is less than equal to x, which is less than 2 pi. Why can I not include both? Are they the same thing? Is 0 and 2 pi the same position? Yes, they're coterminal, right? So they're not, if they said both of them, that would be weird if they're only wanting one period, correct?
So you're just kind of assuming that 0 is also 2 pi?
Well, 0 is 2 pi, but
Okay.
2 pi isn't included in your domain. When you read it in the book, I'm sure it won't have an equal to. Because you would be including the angle twice. Okay, we already had one factored because I screwed it up. I'm sure I did. I don't even remember what it should have been originally. I already showed you the factoring, but it didn't factor nice, did it? So this one will factor nice. We'll work through it and it will factor nice. CJ, can you put your phone away, please? No, like away. I don't want to see it on your desk. Thank you. Okay, so 2 sine squared of x minus sine of x minus 1. That is 2 sine of x squared. So it's the same as saying 2x squared minus x minus 1. Can we factor that?
Yeah.
The factors of 2 that have a difference of 1 are what? 2 and 1. So if I were to factor this right here, I would factor it as 2x plus 1 and x minus 1, wouldn't I? So if I were to factor that original just quadratic formula, this is how I factor it, right?
How do you get just the 2x squared minus x minus 1?
I'm saying we need to think of it as that.
Okay.
Because this whole sine of x is my x, what I'm looking for first. Okay, so my brain needs to see it as an x, as one thing. Okay, because when we're done with our factors, then we're going to set those equal to 0 and go from there. Okay, so if that's what I'm thinking in my brain, is the factorization going to be the same? But this x is going to be not just x, it's going to be what? Sine of x. So it's going to factor to 2 sine of x. And we've already kind of done this. And sine of x minus 1.
Where'd you get the minus 1 in the first one?
Because the factors of 2 are 2 and 1. The factors of 1 are 1 and 1.
It's not
It's on the 2 sine of x, you wrote minus 1.
Oh, sorry.
No, broken.
So I'm going to erase this bottom so I have more room now. So now what am I going to do with both of those factors? Set it equal to 0. So this first one is going to be sine of x equals what?
Negative 1/2.
Negative 1/2. And the second one is going to be sine of x equals 1.
Where'd you get 1/2 at?
Minus 1 divided by 2.
Minus 1 divided by 2. Okay, which one do you want to do first? 1 or negative 1/2?
1/2.
Oh, I want to do that one.
No,
Okay,
that's
so
easier.
this one I need to be thinking reference angle first, don't I? Because it's negative. So my reference angle
5 or 6.
is pi over 6 because opposite, sine is opposite. Opposite of 1 is pi over 6, right? Okay, what two quadrants is sine negative in? 3 and 4. And on my papers, when I do this, guys, this is exactly how I write my answer. Because I have my reference angle, and I have 3 and 4, so I don't miss anything. On the negatives, I'm looking for not 2 answers, but 3, because the reference angle is part of your answer, isn't it?
Yeah.
So what is pi over 6 in the third quadrant? 7 pi over 6. What is pi over 6 in the fourth quadrant? 11 pi over 6. Okay, so sine of 1. Pi, it's only pi over 2, isn't it? Because 3 pi over 2, what is it? It's negative. So if the answer is 1 and it's sine or cosine, I'm only going to have one answer in it, aren't I?
Wait, how do you? Okay, I'm sorry, but I don't get how you get pi over 2.
Because sine is the y value.
Yeah, why don't you just? Okay, but since that's like opposite would be pi over.
Right, but when we're a quadrantal, we don't do opposites, we do the points.
Oh.
So we do the 0, 1 as a quadrantal. And if you think the hypotenuse there is 1 also, so it'd be 1 over 1, so it's 1. Okay, same thing over here, isn't it?
Yeah.
Don't worry about the function. I don't care what the function is. I'm going to think about this like x squared minus 3x minus 2.
It works.
Factors of 2 have a difference of 3?
Maybe.
No, they don't have a difference. If I had a plus 2, would it factor? Factors of 2 add to 3? Yes. So quadratic formula. We have to use the quadratic formula. So a is 1, yes? So it's going to be secant of x equals negative b, 3 plus or minus b squared, so 9, minus 4 times a times c, so 8, all over 2a. So this is 17, right? We can't do anything with that. Too bad it wasn't a negative, then it'd be 1, and square root of 1 is what? 1, but then we would have been able to factor in the first place, right? So now I have secant of x equals 3 plus or minus the square root of 17 over 2. And we're done. And you would put that in your calculator as 1 over the inverse cosine of that, yes? But we're not worrying about that, yes?
How did you know to use that formula?
Because I couldn't factor, because the factors of 2 do not have a difference of 3.
Oh.
If it was plus, could I have factored this, guys?
Yes.
Yes. It would have been secant x minus 2 and secant x, what, minus 1? So x, secant of x, would have equaled 1 and 2, and you would have gone with that, and you would have had to use your calculator, right? So try those, okay? Try every problem. If it's not going anywhere, go to the next one, okay? I did give you odds. There are more than one way to do some of these problems. So don't think you have to do it the way the book does if it doesn't make sense to you, if we did it differently. Got me?
Yes.